In this section, we'll use yet another technique to solve quadratic equations, and this one's called the quadratic formula. You guys are probably already familiar with this. So if you have a quadratic equation of the form ax squared plus bx plus c equals 0, and a does not equal 0, meaning it's actually a quadratic equation with an x squared term, then x equals negative b plus or minus square root of b squared minus 4ac over 2a. So this is your guy. Okay, so these a's, b's, and c's are all coefficients in your quadratic formula. And before you get started, remember to set your equation equal to 0 first before you do anything. Looking here at numbers 12 and 13, they're already set equal to 0, so we don't need to worry about that. But just always keep that in mind. You need to make sure your equation is set equal to 0 first before proceeding. All right, so let's take a look at number 12. It says solve using the quadratic formula. It says x squared plus 4x plus 2 equals 0. So first of all, we want to pull out our coefficients a, b, and c. A is the x squared coefficient, so a equals 1. B is the coefficient of your x term, so that's going to be positive 4. And then c is your constant term, positive 2. So 1, 4, and 2. All right, so filling in our quadratic formula, x equals negative b, negative 4, plus or minus square root of b squared, which is 4 squared, minus 4 times a, which is 1, times c, which is 2. The whole thing divided by 2 times a, which is 2 times 1. All right, so a couple of things I want to point out. One is over here I ask you for b squared minus 4ac. That's going to be this amount that's underneath the square root. So usually that's the most calculation heavy part of this. So let's go ahead and figure that out. So we have 4 squared minus 4 times 1 times 2. So 16 minus 8 gives us 8. So b squared minus 4ac is 8 in this case. So I'm going to rewrite this as negative 4 plus or minus the square root of 8, all divided by 2 times 1, which we can simplify to 2. And then the next step is we want to simplify this square root whenever possible. So we know square root of 8 is equal to square root of 4 times square root of 2, which is equal to 2 square roots of 2. So that means I can rewrite this as negative 4 plus or minus 2 square roots of 2, whole thing divided by 2. And then for my last step, this isn't fully simplified because all of my coefficients here, here, here are divisible by 2. So if you want, you can think of it as factoring out a 2. So if I factor the numerator, that would give me a 2 on the outside, and then negative 2 plus or minus square root of 2 on the inside. And then when I cancel the 2's top to bottom, leaves me with my final answer, negative 2 plus or minus square root of 2. Another approach, when you have negative 4 plus or minus 2 square roots of 2, whole thing over 2, you can also just split this into 2 fractions. You can always do that to play it safe. So negative 4 over 2 plus or minus 2 square root of 2 over 2. You can see the 2's cancel there, and then the negative 4 over positive 2 cancels to a negative 2. So it leaves you with your negative 2 plus or minus your square root of 2. All right, looking at number 13, first we want to pick out our a, b, and c coefficients. Notice that it's already set equal to 0, so we don't need to worry about that. So a equals 1, b equals 7, and then c equals negative 8. So keep an eye on that sign. All right, so putting this into our quadratic formula, x equals negative b, so negative 7 plus or minus square root of b squared, 7 squared, minus 4 times 1 times negative 8. And this whole thing is over 2 times 1. All right, so next up, let's go ahead and evaluate this b squared minus 4ac amount. That's the amount that's underneath our square root. So under the square root, we have 7 squared minus 4 times 1 times negative 8. And that adds up to 81, right? So notice that, do this. Notice that we have 2 negatives there. Negative times negative is a positive, so we actually have 49 plus 32, which is why we end up with a positive 81 under there. Negative 7 plus or minus 81. Whole thing over 2. So that gives us negative 7 plus or minus. Simplifying square root of 81, of course that's just a 9, right? Square root of 81 is 9. So now we have negative 7 plus or minus 9 over 2. And then plus or minus gives us 2 solutions. So using the plus sign, this would be negative 7 plus 9 over 2, which gives me 2 over 2, which simplifies to 1. And then using my minus sign, I'd have negative 7 minus 9 over 2, which is negative 16 over 2, which gives me negative 8. So I have 2 solutions, positive 1 or negative 8. So a couple of things to point out before we move on to the next example. One is keep an eye on your signs. Keep an eye on your signs, right? The 2 negatives multiply to a positive. I see a ton of mistakes when people are simplifying underneath the square root because of sign errors, so just keep an eye on that. Something else I want to mention down here, this was not our final answer when we had negative 7 plus or minus 9 over 2. And I know we left our previous answer as negative 2 plus or minus square root of 2, and we left it with that plus or minus notation, but that's because we can't simplify square root of 2 any further. We can't combine these terms together any further. But down here we have all rational numbers, right? Negative 7 plus 9 over 2, negative 7 minus 9 over 2. So we can fully simplify that to 2 rational solutions. So just be aware of that. We just have plain old numbers, go ahead and fully simplify. All right, looking at number 14, notice that this is not set equal to 0 first. So for number 14, we need to set it equal to 0 before moving forward. Now, you could subtract 4x squared from both sides, but I just like to have that a coefficient positive. I like to have the x squared coefficient be a positive number. So I'm going to choose to subtract 20x from both sides. Let's say subtract 20x from both sides, and then I'm going to add 25 to both sides. So this gives me 4x squared minus 20x plus 25 equals 0. So now I'm going to go ahead and pull out my a, b, and c. A equals 4, b equals negative 20, and c equals positive 25. And if you went the opposite route and subtracted 4x squared from both sides, you would have a equals negative 4, b equals positive 20, c equals negative 25. You should still come out with the same answer. All right, so x equals, now be really careful here. I told you in the last example to keep an eye on your signs, and that's always going to be true. So negative b is going to be negative of negative 20. Negative of a negative is a positive. We have a positive 20 out front. So we'll simplify that in just a minute. So negative 20 plus or minus square root of negative 20 squared. And notice I'm putting that in parentheses. So whenever I square any number, whether it's negative or positive, the square is going to come out positive. That's why I continue to put that in parentheses there. So negative 20 in parentheses squared minus 4 times a, which is 4, times c, which is 25. And the whole thing over 2 times 4. Okay, so let's pause and figure out what b squared minus 4ac is underneath that square root. So typing this into your calculator, I'm going to type it just like I have it. So in parentheses, negative 20 squared. So that gives us our positive 400 minus 4 times 25 gives me 0. So simplifying, negative of negative 20 is positive 20, plus or minus the square root of 0, whole thing over 2 times 4, which is 8. Well, plus or minus square root of 0, the square root of 0 is just 0, so that doesn't do anything. And get rid of that guy. So now we're down to 20 over 8. And simplifying this, I can see that 20 and 8 are both divisible by 4. So if I take 20 and divide it by 4, that gives me 5. 8 divided by 4 gives me 2. So I have my solution, my one single rational solution, 5/2. All right, moving on to x squared minus 3x plus 5 equals 0. It's already set equal to 0, so I don't need to worry about that. So a is 1, b is negative 3, and then c is positive 5. X equals negative of negative 3 plus or minus losing my pen a little bit. B squared, which is negative 3 squared, minus 4 times A, which is 1, times C, which is 5, whole thing over 2 times 1. All right, so let's simplify B squared minus 4AC. In parentheses, my negative 3 in parentheses squared. That's going to give me positive 9 minus 4 times 1 times 5. So that's going to be 9 minus 20, which gives me negative 11. So first of all, my negative of negative 3, that's a positive 3, plus or minus square root of negative 11 underneath the square root over 2 times 1, which is 2. All right, so let's start simplifying this a little bit. One thing we can do is pull out our I. I see that negative sign under the square root, so I'm going to rewrite this as 3 plus or minus I times the positive square root of 11 over 2. And then finally, let's just split this apart into our real and imaginary components. So this gives me 3 over 2 plus or minus the square root of 11 over 2 times I, just making it look nice and pretty. All right, so throughout all of these examples, we were finding what's called the discriminant, b squared minus 4ac. This is the amount underneath the radical sign. And I've labeled each of these 4 examples. In number 12, we saw the case where when we calculated b squared minus 4ac, we got 8. That was a value that's greater than 0. So 8 is greater than 0, it's positive. And remember that when we solved, we got 2 different real solutions as our answers, 2 different real solutions. They were irrational, meaning there's a square root that can't be simplified, but we have 2 real solutions. There's no imaginary unit I in our answers. When we solved number 13, when we were calculating the discriminant, b squared minus 4ac, we got 81, which is positive, and it's a perfect square. And remember that when we solved, we got negative 8 and positive 1 as our 2 solutions. So we had 2 solutions. Well, that zoomed in fast. We had 2 solutions. They were both real numbers, meaning there's no imaginary unit I, but solutions are rational numbers, meaning there's no square root left behind. That's not the formal definition of rational number, but visually that's what you'll see, no square root left behind. All right, then when we got to number 14, we calculated our discriminant, b squared minus 4ac, and we got 0. So this produces 1 real number solution. If you remember, we got 5/2, so we got 1 single real solution. which by the way is rational as well. And then finally in number 15, that's when we had our discriminant of negative 11. So this is the first time that we had a value that's negative, less than 0. And remember that we got two imaginary solutions with those imaginary units I in there. And this is just another format to write your answer. I wrote mine a little bit differently, but same deal. All right, so for number 16, all it's asking us to do is find the discriminant, right? That's all it says in the instructions. Find the discriminant and then determine the number and type of solutions. So all it's asking me to do first is to find b squared minus 4ac. So this would equal, because a is 1, b is negative 12, and c is positive 16. So b squared minus 4ac would equal negative 12 in parentheses squared minus 4 times 1 times 16. So this gives me negative 12 in parentheses squared, which is positive 144, minus 4 times 1 times 16, which gives me 80. So the discriminant equals 80. That's not our solution to the equation, that's not our answer, but the discriminant equals 80. So that's our discriminant. So determine the type and number of solutions. Well, from this lineup, that matches up with this one, right? Our discriminant is positive, but it's not a perfect square. So we will end up with two different real but irrational solutions. So we will end up with two different real, irrational solutions. And if you want, go ahead and solve this equation and get your two answers and make sure that that matches up. So you should end up with two different real answers, so no imaginary unit I in there, and you should have a leftover square root in your answer, in both answers.